Hello everyone. As software development engineers, we come across a lot of tasks and challenges that might seem pretty difficult to address in the beginning. So in these cases, what we do as a best practice, we start tackling small challenges first. We divide the problem into small pieces, tackle those pieces, solve for those pieces first, then put everything together. Now, this video will be devoted to such a practice, and we will call it incremental development, or developing piece by piece. Now, we're given a task that asks us to find the distance between 2 points on a plane surface defined by coordinates x1, y1 for the first point and coordinates x2, y2 for the second point. Basically, we're asked to find the distance between two given coordinates. Now, every time you come across a task, if you can't just jump in and solve for it right away, best thing to do is, actually before even jumping and solving for it, even if you know the answer right away, best thing to do is analysis and pseudocode development. You need to take a step back, look at the question, understand the challenge, try to explain how you're going to solve it in plain English, then start coding for the English solution that you just came up with. Now, our analysis stage is all about understanding what we're being asked, and pseudocode development is all about how we're going to solve for this challenge. Before we dive into our eclipses and start coding for anything, let's actually find a plane surface. Let me get a new tab, and what we're going to do is we're going to search for, so best representation of a plane surface is going to be x and y axis graph, x and y graph. Let's search for it, go to images, find a pretty simple one. For example, this is a great example, right? X and y axis, point given by coordinates 1 and 2. And let's actually build on this. I'm going to copy this image, and I'm going to actually get a PowerPoint presentation. You can work with photos as well, whichever one is comfortable for you. And let this load. And we'll start with a blank presentation. Let's just paste that. Okay, let's open it up. Let's just paste that plane surface here and work on this. Okay. Design ideas, thank you kindly. No. Let's open up our home, and we will want to draw certain shapes. Now, we're given a point defined by x1 and y1. x1 here is 1. This is our x-axis. y1 here is 2. Great. Now we have one coordinate by default. Let's actually just create another coordinate, and let's place another point at x5 and y5. Let's do that. Yeah, and to do so, I'm just gonna use a shortcut. I'm just gonna do this, and we're gonna say this is our second point. And here, I will try to add a text. Text direction, align text. So let's go to insert, text box, and we're going to call this coordinate. X is going to be 5, so 5, and y is going to be 5. Okay, and we're gonna follow the suit. We are going to color it red, the same way as below. Okay, so now we have 2 points. How can we find the distance between 2 points? One solution is to use a Pythagorean theorem. So let me actually create virtual lines. This is line 1, and let's make it thicker so it's visible, right? And can we make it a little bit more? Yeah, here you go. This is line 1, I'm going to copy, paste it, and this is my virtual line 2, imaginary line 2. So Pythagorean theorem says that to find the distance between this point and this point, so between these 2 points, which in an imaginary way creates a right triangle, I can take a distance between, I can take this length, take it square, I can take this length, increase it to the power of 2, so find its square, and then this length here is going to be the square, the addition of these two is going to be the square of the length here. So let's create another line, and we're going to say that, and we're going to give these lines names. So we're going to say, let's add text, one here, oops, not that one. So where's the, okay, add insert text. We're just right now analyzing and designing. So this is what I'm going to find. This is, I'm going to call it distance. So distance squared based on Pythagorean theorem, e squared. This is going to be, for let's call it side A, is going to equal to A squared plus E squared, right? So I'm going to paste it and I'm going to put it here. So Pythagorean theorem says that E squared is equal to A squared plus B squared. So if I find that this, if I find what A is equal to, increase it to power of 2, then I find out what B is equal to and increase it to the power of 2. Then if I take these and find their square root, if I find the square root of this operation, this arithmetic addition, then I will find D. I will solve for D. Now, what is A equal to? A is equal to the distance between this one point's y coordinate and the other point's y coordinate. So distance between 5 and 2 is going to be equal to A, right? So let's do this. I'm going to add here A is equal to y2, right, minus y1. So 5, that is coordinate of the second point, minus 2, the coordinate of the first point. And therefore, continuing this suit, A is equal to 5 minus 2, correct? Right? A is equal to 3. Great. Now, what is B equal to? B is the distance, is the difference, or let's call it distance between 5, which is x coordinate of the second point, and 1, which is x coordinate of the first point. So following the same suit, let's get to the end of it. We're going to say B is equal to x2 minus x1. And let's put some space here. Great. Also, B is equal to x2 was 5 minus 1. B is equal to 4, right? Now, by creating this virtual triangle, we actually find out 2 things. One, we can simply take find the difference between y2 and y1, say it's one side of a triangle. Then we can find the difference between x2 and x1, say it is the second side of a triangle. Then we can add their square solutions, right? We can add their power to the 2 solutions. We can find that d squared is going to be equal to that. So Having said these, we know that A is 3, B is 4. Let us actually put this here and see what happens. So D squared is equal to 3 squared, so which is equal to A, right, plus 4 squared. Now, D squared from the given, from the example above is equal to 9 plus 16. D squared is equal to 25. So obviously 5 squared is equal to 25, right? So 25 is equal to 5 squared, which is also a representation of 5 increased to the power of 2. So from here, D is equal to 5. Obviously, the distance between these two is equal to 5. If you want to find that out, this is our distance, right? We can take it, put it in a plane level right here. And this is actually, okay, I actually should not have changed it. So basically, if this is given a Pythagorean theorem, and if you Google it to look into the details, do so. So basically, from this simplification, from this analysis, we found out that we need to do the following. Now we're going to write our pseudocode. Step number 1, so this is our pseudocode. Step 1, find the difference, or the distance, let's call it by their names. Find the distance between x2 and x1. Step 2. So the x2 and x1, we are going to call this side A. Did we do the same here? Side A is actually side B. We're going to call this side B. Then we're going to find the distance between y2 and y1. We are going to call this side A. Step 3, we are going to add the square, or we're going to add A squared and B squared. Step 4, we are going to find the square root of the result from step 3, right? We're going to find the square root of the result from step 3, right? Like we did here, correct? Then that's going to be our distance. Step 5, result from step 4 is our distance. Return it, because we're going to create a return method. Given 2 coordinates, we're going to return the distance. Return it. That's it. One more time. What we're going to do is this. We're going to find the distance between second coordinates. We're going to find the distance between first. So we're going to find the distance between y coordinates. We're going to find the distance between x coordinates. Then we're going to increase both of those distances to their square powers. Then we're going to add those results, and then whatever the result is, we're going to put it in the square root. That's going to be our distance between 2 points. Okay, now that we have the understanding, now that we have a visualization, let us start coding for it. So let's go to our Eclipse. Within our section 3_4, we're going to create a new class. We're going to call it distance calculator. Finish. Let's create our main methods. We're gonna, for now, leave it blank. Now we're gonna declare our distance method. Now when we're gonna declare it, we're gonna this time return a double, because the input might be in double numbers, because distance can be miles, in kilometers, etc., and it can have some decimal points. So we're gonna return a double to be safe, and we're gonna call it distance. And this here is going to accept all 4 double values: double x1, double y1, this is our first coordinate, double x2, and double y2, this is our second coordinate. Correct? This is our coordinate. These are our coordinates for the first point. These are our coordinates for the second point. And with the standard, this is a common development thing to do. What you do is, the moment you declare a method, in order to avoid your IDE from complaining, in order to stop it from complaining, you just return something. You just return a dummy value. And usually you return the default value. If it was an int, we would return -1. If it is a Boolean return, if it's a Boolean method, we would return false. With double methods or floating point returns, we return 0. Okay? And following good practices, we just create our documentation. And we have task definition here. We just can copy this, paste here, and let's adjust them. Great. Parameter x1 is going to be x coordinate of the first point, y coordinate of the first point, x coordinate of the second point, and y coordinate of the second point. And I kind of forgot it. So of the second. Great. We have our method definition. Let's test if everything is working fine. So what we're going to do is we're going to just print out our method return, see what it returns. We're going to call our method within the print statement. We're going to pass in anything. Actually, let's pass in the values that we worked on while we developed our pseudocode. First coordinate x for the first point was 1. Then 1 and 2 are the x and y coordinates. If you actually want to have Eclipse IDE help you with making sure you type the right values, just call the method, control space, it will create the body of it for you. It will create the parameters, list of parameters for you. Okay, so x1 was 1, comma, y1 was 2. And x2 was 5, y2 was 5. And these are supposed to be double values. So let's just add zeros to the end, 0.0. These, by adding 0.0, we're converting them to double values. Run this code, and it will return 0, right? Because that's what we said it should return. Now inside, let's do this. Go back to our pseudocode. Step 1, find the distance between x2 and x1, and we're going to call this side B. Great. Now code for it. Double side B is equal to x2 minus x1. Now, there is one thing that you need to remember. I mean, I can code this and get to a point where we run into a mistake, because what if the values are negative coordinates? So for finding a distance, math class provides absolute method that always returns the absolute value of whatever is passed in as a parameter. In this case, we're passing in a arithmetic operation of 2 doubles as a parameter. So whatever this difference is going to be, it's going to be always returning a positive value. And in any case, even so, distance between 5 and -2 is not 3, correct? Distance between 5 and -2 is 7, because 5 squares you move here, 2 squares you move to the left. That's why we're going to use math absolute. Going back to our pseudocode, step 2, find a distance between y2 and y1 and call this side A. Great. Double side A is equal to math.absolute, distance between y2 minus y1, our distance. Okay, great. Step 3, we are going to add a squared, a squared and b squared. Great, let's add that. So we're gonna call it double squared is equal to side A to the power of 2 math dot let's see, we have, no, this is square root, right? Math dot power, first number, read the documentation, returns the value of the first argument raised to the power of the second argument. Great. So we're gonna, the side A as a first argument is going to be raised to the power of 2. Great. Plus the same, but with side B. Now this squared holds our result, but it's squared value. Then we're going to return, you can create double result, and internal variable here is going to be equal to math.find the square root, returns the correctly rounded positive square root of a double value. So square root of squared, and you can return that as a result. Or we know that you can simply take this and pass it here as a result. But let's not go ahead of ourselves, and then let's just see if I pass in these, if we pass in these values, are we going to get 5 as a result, as a distance between these two values? Answer is yes. Let's do this. Let's go online and search for distance calculator. X and Y, between distance calculator X and Y. 2D distance calculators, let's look into that. Okay, great. Now that we have developed our method, now it's time to test. Either we're going to create multiple test values, which is usually going to be the case, but in our case, since we have someone that has already developed it, and we are going to take a leap of faith and trust this, we are going to do this. We are going to pass in values here, and we're going to pass in the same values in our method. For example, there are sample values, -7, -4, and the answer is 26, 19, 60, 74. Let's take these values and pass them into our code. See if our code actually performs the way it's supposed to. So x1 and y1 are -7 and -4. So up here, we're going to pass them here, -7, -4, and the second coordinates are going to be 17 and 6.5. We're going to actually test here for negative values. We're going to test to see whether our method has been developed in such a way that it is defect free, that it can work with negative values as well. So come in here, pass them here, and let's just convert them to a double in order to avoid any confusion, and run this code. Voila, we got 26, 19, 63, 73, etc., etc. And let's go back and see what the distance here is, 26, 19, 63, 74. So they have rounded it to the last 6 points. So they have rounded it up to here, 74. You want your distance to look good, you want your result to look even better, you can use math.round. But the problem with this is it is going to return a long or an int value. The problem is, in that case, we will not be able to return a double. Okay, now we have not seen method overloading. Actually, the next thing we will see in this section is going to be method overloading. So this was a demo of how we can solve for a task that seems pretty difficult in the beginning. I mean, how could you have gotten distance between 2 points? So we found out that the best thing to do is to use Pythagorean theorem, right? Because Pythagorean theorem says that so the distance between point A and point B is equal to the sides squared, and then the total calculated, the square root of the total as taken, that's going to be our distance. So distance squared is equal to one side squared plus another side square, okay, by creating a right triangle. We took our way from here. We created our pseudocode. What we're going to do, we actually put it in English. Then coding part was the simplest part because we just took the English and translated it into Java. Can you make this better? Yes, you can make it much better. You can actually avoid writing these side A's and side B's. You can take these and pass them inside methods. You can do method chaining, method nesting. However, it is better to keep your codes like this because it's better to add comments here. So finding the distance for side A or the length for side A, etc. Or this is the first one, is side B. So add comments here, add comments here, what you're doing. So add comments all over the place. And then when it comes to returning, you can, instead of creating a result variable here, you can just return math.square root. Okay. In the next section, we will see overloading, and keep this in mind. Create this class in your Eclipse. Save this program. Google distance calculator X and Y, something like this is going to come up, calculator soup. Put in random numbers here and take this, find the result, take the same numbers and add them into your test values. Test your method for any defects. Next, we will keep this method, and as a assignment, after you see overloading, keep this method as is, overload it so as it returns an int value. Okay, and then instead of getting these points, you're gonna be getting these decimal floating points. You're gonna get precise number. I want to thank you for your time. I hope this helped. Remember, huge programs are developed one step at a time using very similar approach. By understanding what the problem is, creating a pseudocode for it, and then coding from English pseudocode into Java or any other language per se. Again, thank you. I'm looking forward to seeing you in our next video recording.